Before you is not just trash. These are the remains of a digital civilization. Server racks that once processed billions of operations per second are now silent. In a world where artificial intelligence demands ever-increasing power, resources are becoming the new oil. To build new superchips, we need the rarest metals on Earth. Extracting them from the ground is no longer as efficient as extracting them here. Welcome to the urban mine. Hidden among thousands of kilograms of silicon and plastic lies the very material that built empires. Pure gold. Today, we will travel the full path, from dead electronics to a shining ingot of 999 purity. The process begins with surgical precision. Motherboards and RAM sticks contain gold on their contacts, the fingers that ensure data transmission at super speeds. Gold isn't used for decoration. It is used because it is the ideal conductor that never oxidizes. 1 ton of this electronic waste contains 50, sometimes 100 times more gold than a ton of rich, natural ore. Mechanical manipulators and the hands of engineers separate the gold-plated parts from the useless fiberglass. This is the concentrate, the most valuable part, which will now begin its chemical journey. In the sterile zone of the laboratory, the magic of chemistry begins. To reach the gold, we must destroy everything else. We use nitric acid. It is aggressive against copper, nickel, and zinc, the base metals that hold the gold plating. The moment the liquid touches the scrap, a violent reaction begins. Thick brown fumes of nitrogen dioxide are released. This is dangerous, so the process takes place within powerful fume hoods. The acid literally eats away the base, liberating the microscopic gold foils to float in the solution. The gold itself is inert. It remains untouched, simply freed from the shackles of cheaper metals. Now we have pure, but physically dirty, gold flakes. To make it perfect, we must make it disappear. Alchemists of the past called this liquid Aqua Regia, royal water. It is a mixture of hydrochloric and nitric acids. This is the only substance capable of dissolving the king of metals. As it heats up, the solution turns a deep orange. The solid gold breaks down at the molecular level, turning into chloroauric acid. The metal is now hidden inside the liquid itself. This is a critical moment. If even a single particle of dust remains, the final ingot will be brittle and useless for high-end electronics. The liquid is now our gold. It must be purified of the slightest impurities, dust, plastic residue, or fiberglass. The solution is run through a vacuum filtration system. Drop by drop, the saturated solution falls into the flask. Look at this color, a deep, clear, amber hue. In this flask, a small fortune is dissolved. But for now, it is just a toxic liquid. Ahead lies the most spectacular stage, returning the metal to a solid state. We must neutralize the acid and force the gold to fall out of the solution. we add sodium metabisulfite. The reaction is instant. The transparent solution turns cloudy, darkens, and a heavy suspension begins to settle. At the bottom, it looks like mud or wet sand, but this is actually the purest gold, simply in the form of microscopic particles. Chemical bonds are broken, and the metal returns to its elemental form. We let gravity do the work. The heavy sand settles to the bottom, and the liquid above becomes clear again. Chemistry has done its job. Now, we pass the torch to physics and fire. The sediment is washed with distilled water to remove any remaining acid. A single drop of chemicals can ruin the melt. Then comes the drying phase. Under the influence of heat, the moisture evaporates and the mud turns into a light brown powder. It is hard to believe, looking at this pile of dust, that before us is one of the most coveted materials in the universe. The powder is poured into a ceramic crucible. This is the cradle for a future star. We add a little borax. It acts as a flux, which will make the metal flow and trap any remaining micro-impurities in a glass crust. The melting point of gold is 1064 degrees Celsius. The oxyacetylene torch delivers 3 times that heat. Under the roar of the flame, the powder begins to glow red, then blindingly white. And here it is, the moment of phase transition. The dust collapses into a single liquid sphere. Due to surface tension, the drop is perfectly round. It spins in the crucible like a miniature sun, a liquid mirror reflecting the flame. The impurities are trapped on the crucible walls. In the center, there is only absolute purity. The engineer carefully lifts the glowing crucible. One wrong move could be fatal. The liquid metal pours into a graphite mold, heavy and viscous, like honey. Crystallization happens in mere seconds. The bright glow fades, and the metal hardens. Gold is a soft metal, but as it cools, its atoms lock into a rigid crystal lattice. Right now, this bar is still hot and covered in a thin film of oxidation from the mold, making it look matte and dull. It needs the final touch. The cooled ingot is dropped into water. Steam hisses. And finally, the polish. The soft wheel removes the top layer, revealing the true face of the noble metal. A deep, rich, yellow color that will not fade even in 1,000 years. We started with a mountain of electronic waste. We passed through acid, toxic smoke, and hellish fire. And we achieved this. A perfect ingot of 999 purity. Most likely, this gold will be sold to electronics manufacturers. It will be melted down, drawn into wires as thin as atoms, and placed into the heart of a new AI processor. The circle is complete.